Today we are going to start the next exercise 2.7 from the chapter number 2 fractions and decimals. Now if we discuss some facts regarding the exercise 2.6, then actually in exercise 2.6 we had taken the product of two or product of decimal number and whole number or product of two decimal numbers. That means here we are dealing with the decimal numbers and we had taken the product of decimal numbers in exercise 2.6. So different criterias are there, like we had taken the product of two decimal numbers, or we had taken the product of one decimal number and one whole number. Now here the same thing we are going to perform. That means again we are going to consider the decimal numbers. That means again this exercise is depends on decimal number, but the operation is going to be different. That means here we are going to consider the division. Here we are going to consider division. That means we are going to consider the type of example like decimal numbers are divided by whole number. Like this category we are going to consider in the question number first of the exercise 2.7. Now as we have seen that in the exercise 2.6 that if we are multiplying by 10, that means whole number is going to be 10, 100 or 1000 like this. Then in that case we are shifting the decimal point to the right side. Actually we are shifting the decimal point to the right side by number of zeros. So you have to count the number of zeros and then those number of digits should be shifted to the right side. So that is the first method we had seen. And the second method is that for a temporary purpose, or in order to perform the calculation, we are ignoring the decimal point, and afterwards, that means after performing all the calculations, then we are taking that decimal point back. That means we are again bringing that decimal point, and then final answer is obtained with the help of those decimal point. Now actually while performing the division of decimal number and whole number, here again we are going to consider the same previous method. That means some steps are we are going to take from the previous exercise and some steps are going to be newer. Now here the first example is like this: 0.4 divided by 2. 0.4 divided by 2. Now here the first number is decimal number and second, that means divisor, is a whole number. Divisor is a whole number. Now here if we consider the division, here the division is like this: 0.4 divided by 2, and while considering this division, again we are going to consider the first step, that is ignoring the decimal point. That means here we are going to ignore the decimal point. So after ignoring the decimal point and 0 which is present before the decimal point, so we can also ignore that 0. So therefore the next step will be like this. We are getting the numbers like this: 4 divided by 2. 4 divided by 2. So the next step is like this: 4 divided by 2. So here we haven't do anything. We had just ignored the decimal point for a temporary purpose, and then after ignoring that decimal point we are getting the both whole numbers. So we are getting like this: 4 divided by 2. 4 divided by 2. Now you know the 2's table. That means you can easily divide this 4 with the help of 2. That means if you are going to divide this 4 with the help of 2, then you know that 2 2s are 4. 2 2s are 4. Then 4 minus 4, the remainder is going to be 0, and in this way you are getting the solution 2. That means the quotient is 2. So therefore here we can say that 2 2s are 4. 2 2s are 4, and therefore 4 divided by 2 is going to be 2. So here the division is 2. So first of all, we had ignored that decimal number, that means decimal point, for a temporary purpose. Then we had divided by 2 to the given number 4, and after dividing 4 by 2 we are getting the final answer as 2. Now our purpose is satisfied, that means the purpose for which we had ignored that decimal point, that is completed, because we had completed the calculations. Now the next step is that we have to brought that decimal point again on its original places. So after bringing that decimal point to its position, again we are getting our original calculation, which is 0.4 divided by 2. So that original calculation is obtained. Now in the previous exercise we have seen that the after bringing the decimal point, we are counting how many digits are present after the decimal point. So same thing we are going to perform here. We have to count how many digits are present after the decimal point. We have to count how many decimal digits are present after the decimal point. So here don't see that which digit is present, which number is present, 4, 5, 6, 9, 0, any number can be possible. So here we have to only count the number of digits which are present after the decimal point. So here 2 is a whole number, so there is no need to count the decimal digits in the whole number 2, so that will be cancelled. So remaining decimal number is 0.4, and in this decimal number only a single digit is present after the decimal point. Only one digit is present after the decimal point. So therefore in the final answer also one digit should be there after the decimal point, and that one digit is only 2. So therefore before 2 we are going to put that decimal point, and as before decimal point no number is there, so we can place 0. So therefore we are getting the final answer as 0.2 by dividing 0.4 with the help of 2, and in this way we can able to solve such a type of example where decimal numbers are divided by whole numbers. Now the second example is 0.35 divided by 5. 0.35 divided by 5. Now here if we consider the decimal number, which is 0.35, and here clearly if we measure how many digits are present after the decimal point, then those are 2. So here 2 decimal numbers or 2 decimal digits are available after the decimal point. So therefore again afterwards we are going to count how many digits are present. So here 2 digits are present, so that means in our final answer again we are going to obtain the 2 digits after the decimal point. Now the first step is that ignoring that decimal point. So we have seen these steps. We are going to ignore the decimal point, and after ignoring that decimal point we are getting 35 divided by 5. That means this 0.35 is converted into whole number. This 0.35 is converted into whole number. So here now we are going to divide 35 by 5. That means here we are going to perform the division. 35 is going to be divided by 5. Now actually you know that 7 5s are 35, but here we cannot use that direct method, so you cannot say 7 5s are 35, but here we have to use the proper method by using our division method. So here first of all we are going to divide by 5 to the number 3. Where we are going to divide, we are going to divide 3 by 5, but we know that 3 is less than 5, so it is not divisible by 5. So therefore we are going to take 0. We are going to take 0. Okay. Then 5 0 0, 3 minus 0, that is going to be 3, and again this 5 will be carried as it is, that 5 will be carried as it is. So we are getting the number 35. Now we can say that 5 sevens are 35, 5 sevens are 35, and 35 minus 35, the remainder is 0. So that means it is perfectly divisible. It is perfectly divisible. So therefore, either you can write down 0 7 or you can write down 7. That means here question can be considered either 0 7 or only 7. So any way you can take the same number. Either you can take directly 7 or you can take 0 7. No problem. You can take any number. Now again we have to bring that decimal point. So here after the decimal point, total 2 digits are there. Therefore in the final answer also we are going to consider 2 digits after the decimal point, and those 2 digits are 0 7, 0 7, and we are putting that decimal point before 0 7. So therefore we are getting the two number of digits which are present after the decimal point, and therefore 0.35 divided by 5, that answer is going to be 0.07. 0.07 is the final answer for that division, 0.35 divided by 5. So this is the answer of second sub question. Now we will move to the third sub question, which is 2.48 divided by 4. Now initially in the decimal numbers 0 is there, but here 2 is there. Instead of 0, that 2 is there. So if we consider the number is like this, 2.48 divided by 4, and here we are going to perform the division of these two numbers, 2.48 divided by 4. Now here again same methods we are going to follow. We are going to ignore the decimal point for a temporary purpose. From 2.48 we are going to ignore that decimal point, and after ignoring that decimal point, remaining numbers we are going to write down as it is, 248. That means 248 divided by 4. 248 divided by 4. So here we are going to perform the division of these two numbers. That means we are going to solve it now like this, 248, and we are going to divide this number by 4. 248 divided by 4. So we are going to divide it now. We know that 4 6 are 24. 4 6 are 24. So first question is 6. Okay. 24 minus 24, that is going to be 0. 24 minus 24, that is going to be 0. Then we are going to bring this 8 downside as it is. So which number we had obtained? 8 number we had obtained. So now you know that 4 2s are 8. 4 2s are 8. Again 8 minus 8, that is going to be 0. So therefore 248 is perfectly divisible by 4, because we are getting the 0 as a remainder, and here by dividing 248 with the help of 4, we are getting the quotient as 62. So therefore the final answer is 62. Final answer is 62. Now here again we have to bring that decimal point, and here if we see the number 2.48, then it is clear that after the decimal point 2 digits were there. 2 digits are there. So therefore in the final answer also there should be 2 digits which are present after the decimal point, which should be present after the decimal point, and therefore by keeping the decimal point before 62, we are getting the final answer as 0.62, which is the division of 2.48 divided by 4, whose final answer is going to be 0.62. In this way, we can divide the decimal number with the help of whole number, decimal number with the help of whole number. So this is the exercise 2.7 question number 1, in which we are dividing the decimal numbers with the help of whole numbers.